Here we have linear transformations from R3 to R3, and we are going to solve for the standard matrix of said linear transformations. So we're going to do it for the first linear transformation as well as for the second here. But of course, the standard matrix of a linear transformation will depend on the standard matrix of our domain, which is R3. The standard matrix of R3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. Sorry, 0, 0, 1. This is called the standard matrix because all the matrices in this domain are generated by this. So to start, let's proceed to our first linear transformation here. We are going to take out the columns here and say the first column is the E sub 1 vector. So you have 1, 0, 0. The second vector, E sub 2, would be our second column, 0, 1, 0. And our third vector is the third column, 0, 0, and then 1. What we need to do here is to take the linear transformations using the three vectors and combine them into an augmented matrix to solve for the standard matrix of the said linear transformation. So we have here the linear transformation of the first vector, 1, 0, and 0. Meaning 1 is x, or x is 1, y is 0, z is 0. And since we have here its equivalent linear transformation, so z is 0, 0, and then 1. That's the linear transformation using the first column. For the second column, E sub 2 is a linear transformation of the 0, 1, and 0. By the way, you could rewrite this in this manner. Linear transformation of 1, 0, 0 is equal to 0, 0, 1. Okay? Now for this, we have here 0, 1, 0, so x is 0 and z is 0, so it's just 0, 1, 0 as well. Again, you can rewrite it this manner. 0, 1, 0 is equal to 0, 1, 0. Okay? And finally, you will have the linear transformation of our third column. You will have here linear transformation of 0, 0, 1 equal to so x is 1, so that's a 1, 0, and 0. Again, this could be expressed in this manner, 0, 0, 1. Then you have here 1, 0, and 0. Now, the standard matrix of a linear transformation is when we are going to come up with the augmented matrix of all the linear transformations. So you have here linear transformation of E sub 1, linear transformation of E sub 2, and the linear transformation of your E sub 3. So our standard matrix here is this result first, 0, 0, 1, the next 0, 1, 0, and finally that's 1, 0, 0. This is the standard matrix of the first linear transformation. Let's proceed to the second here, as we are going to take this as well. So E sub 1 is the vector of the first column. We have E sub 2. I'm going to make it thicker because we're a representing vector. And we have here E sub 3, 0, 0, 1. Okay. And this would be its equivalent. So we need to take time here in solving for this, since we might have different results if we are going to rush all of these things. So we are going to start with the linear transformation of the first column, which is the linear transformation of 1, 0, 0 in vector form. So this would mean x is 1, y is 0, z is 0. So we have 2 times 1 plus 3 times 0 minus 0. The second entry, 3 times 1 minus 2 times 0. And the last entry, 2 times 1 minus 0 plus 0. So next, you will have this form here. 2 plus 0 minus 0, 3 minus 0, 2 minus 0 plus 0. Okay, so the form here for the first is we have 2, 3, and 2. Or you could rewrite this as a form of a column. You will have here 2, 3, and then 2. That's for the first, okay? The first form. Next, let's proceed to the second. Okay. Let me use the space here so I could still see this. E sub 2 is equal to linear transformation, of 0, 1, 0. So this is x is 0, so 2 times 0 plus 3 times 1 you have here, minus 0, which is our z. Then 3 times 0 minus 2 times 0, 2 times 0 minus 1 plus 0. That's 2 plus 3, not 2. That's 0 plus 3 minus 0, 0 minus 0, 0 minus 1 plus 0. So the result here is 3, 0, and negative 1. This would be our form here for the second. 0, 1, 0 is 3, 0, and then negative 1. And let's have the last here. E sub 3. This is linear transformation of 0, 0, 1. Okay, let's start. We have here this form, 2x plus 3y minus z. So 2x plus 3y minus z. Next, 3x minus 2z. 3x minus 2z. And finally, 2x minus y plus z. 2x minus y plus z. So that's 0 plus 0 minus 1. 0 minus 2. 2, that's 0, 0 minus 0 plus 1. So you have the form negative 1, negative 2, and positive 1. So our form here is in this manner. You will have 0, 0, 1 is equal to negative 1, negative 2, and positive 1. So all of this will be combined into 1. You have the linear transformation of the first column, linear transformation of the second column, and the linear transformation of the third column. So the standard matrix for the second linear transformation, we have 2, 3, 2, this one here, then 3, 0, negative 1, this one here, and then negative 1, negative 2, and positive 1. So this is how we show the standard matrix of the linear transformations using these definitions. Thank you very much for watching.